Now let us see another example of composite section. So we are having a RCC column 500 in diameter, and it is reinforced with 6 steel bars of 20 diameter. We have to find out the total load carrying capacity of the column if the permissible stresses in concrete and steel are 4 MPa and 130 MPa respectively. Take modular ratio as 18. Now let us solve this example. So total area will be equal to pi by 4 d square, where d is 500 So total area will be 196349.54 square. Now there are 6 steel bars as shown in the figure. So therefore area of one steel bar is pi by 4 d square. Such 6 bars are there. So 6 into pi by 4 d square. So that value comes out to be, and value of steel rod diameters or steel bar is 20 So it is pi by 4 20 square. That is 1884.955 square. We have to find out the total load carrying capacity of the column. If stress in concrete is 4 MPa and that of steel is 130 MPa. Now the area of the concrete will be this total area minus area of these 6 steel bars, so that we'll get the area of this cement concrete. So ACO will be total area minus area of 6 steel bars. So substitute the value of total area and area of steel bars, 6 steel bars. So we'll get the area of concrete, that is 194464.585 square. Now using these values, we have to solve the example. So we can say that strain in steel is equal to strain in concrete, or deformation in steel is equal to deformation in concrete. So strain is nothing but stress upon modulus of elasticity. Here also sigma upon E of steel is equal to sigma upon E of concrete. So sigma st upon est will be equal to sigma co upon eco, cross multiply by this est, so that we can able to express this sigma st in terms of sigma co. Now est upon eco, this is the modular ratio, and this modular ratio is given as 18. So we can say that sigma st will be equal to 18 times sigma co. Now total load is equal to load taken by steel plus load taken by cement concrete. So it is PST plus PCO. Now force is equal to stress into area. So in place of P, we have substituted stress into area of steel plus stress into area of concrete. So sigma st into AST plus sigma CO into ACO. Sigma ST is 18 times sigma CO from equation 1. So that value we have substituted. So in place of sigma ST, it is 18 CO. Now this sigma CO is common from both these terms. So it is 18 into AST plus ACO. So substitute all those values, because sigma CO, AST, ACO and 18, they are all known to us. So we'll get the value of total load that is taken by the given particular bar. So it is 913.57 into 10 raised to 3 Newton.